Now, I'm going to keep this very simple, and if you want to know more about them or more detail on this, feel free to Google any of these topics. There are huge Wikipedia articles on them, huge studies they've done online, but I want to keep it simple for you guys so I don't have to waste your time with any of this. So let's go over this quickly. Number one, and the simplest way to know we live on a round Earth is because of math. It's something known as spherical geometry. Basically, because of how round and big the Earth is, if you draw a giant triangle, it doesn't equal 180 degrees like it would on a flat plane. That's as simple as it gets, and the only way this is possible is if we live on a round Earth. Otherwise, it would work. It would equal 180 degrees every single time, and it doesn't. Now again, like I said, on a small scale in your hometown, in my city, it would work, but on a global scale, when we measure these things, it doesn't work. And that is how, through simple 6th grade math, using a very simple set of right and acute angles, we can see that the Earth is round by default. So if you graduated 6th grade and you understand geometry, boom, there you go. You have now proven that the Earth is round.
So here's the bottom line new revelation, guys. Make yourself an equilateral triangle, 360 degrees, do it on paper, do it something flat. 3 60-degree turns, equilateral, same lengths each side, A, B, and C. Lay it down on Google Earth. And of course you'll be able to bend it at the ends, won't you, because it's a sphere. Mark the distance between cities, go to Google Earth and measure it out, and guess what? They're all going to be equal. You know why? Because the Earth is flat. And if they didn't give you the measurements on a flat Earth, people would realize, wait a minute, I know it's a lot closer from this point to this point. This doesn't make sense, Google Earth. Try it. Go ahead and try it. You're going to find out that the impossible, everybody bought into it, didn't they? It's impossible to have 360 degrees equilateral triangle on a sphere. Lay it out, take down the edges if you want, measure it on Google Earth, see what the distances are. Be very accurate, and you'll find out they're within 50 miles, which they should be much different if it's a sphere. The Earth is flat, guys.
The second reason, and one that has a lot to do with something we see pretty much every night, is Mr. Moon. How does the moon prove the Earth is round? Because if you look up at the moon right now, I'm not sure what phase it's in, but you'll probably see a curve of a shadow on the moon. Now, if we lived on a flat Earth, there would be a straight line going through the moon because that shadow would be straight. The only way that shadow can be curved is if the world is a sphere, because that's what a sphere does. It has a curved shadow. That's our second example, and it's that simple. Three, which is pretty simple to see, especially if you live near the beach, is how the horizon curves. We can see it with ships on the horizon. Again, if we lived on a flat Earth, technically with a powerful enough telescope, I could see any point on the whole planet from a high enough vantage. And that's as simple as it is. I could see anywhere I wanted on all of Earth if I was high enough up in the sky. But we can't. Even at ground level, we as humans only have about 4 miles of our field of view, which is why as soon as a boat starts getting about 4 miles out in the water, it starts disappearing below the water. If it was a flat Earth, it would just keep getting smaller and smaller, going straight, not dipping below it.
Now, you know, the scientists will say, oh, refraction and this and light bending around the Earth and stuff. But the fact is, you know, it's perfectly flat. Many arguments that show that, no, many experiments that show the Earth is always perfectly flat. They say that you see the mast, you know, go down last. Is literally just the way your vision works. Yeah, it's perspective and atmospherics basically. The limit of your vision is supposedly 3 miles, and then after 3 miles you're supposed to see the boat start to go over the horizon. It's funny that Neil deGrasse Tyson again says that explains that you can't see the curvature of the Earth from a plane. He says this, you can't see the curvature of the Earth from a plane because you're not high enough. The Earth is so big that you can't get high enough to see the curvature, yet you can apparently see a boat go over the curvature over the distance of 3 miles, which doesn't make sense. The thing is, when you look out and you see a boat start to go over the horizon, if you suddenly get a pair of binoculars and look, it comes back again. And once it goes out of the sight of your binoculars, if you get a telescope, yeah, it comes back again. It doesn't go over any curve of the horizon. What we found, many people have done experiments with very high-powered zoom cameras, and they've watched a boat sail out to sea, and they've just kept trained on this boat. And what they see is, after a very long distance, you see an atmospheric effect where the bottom of the boat disappears and the top of the boat inverts, so you see a sort of mirror image. And that, with your eyesight, basically the bottom of the boat just melts into the horizon. One of the best examples of that is the Antwerp Notre Dame spire, which can be seen something like 240 kilometres away from the spire. So that should be over a mile below the horizon, and you can still see it.
And so there we have it, the truth, the light, the honest answer, and the facts behind it as to what kind of Earth we live on. Now, I know you've seen doctored pictures and cool Photoshop and these trendy little things online that show the Earth is flat, but it's simply not true. There's a difference between fallacies and facts and a presentation of a point that holds merit in the scientific community with something this important and this huge, and then something that doesn't.